During most power outages, the device people worry about losing least is the one they actually need most. Not the fridge, not the lights, the phone in their pocket, which is often the only way to check emergency alerts, contact family, or call for help once the grid and cell towers are both under strain. A $9 hand crank generator, small enough to fit in a junk drawer, can keep that one device alive indefinitely, with nothing to plug in and nothing to run out of. There's a number buried in that claim that decides whether indefinitely is realistic or wishful thinking, how many minutes of actual cranking it takes to produce 1 minute of talk time. Most people who buy one of these never check that number, and that's exactly why so many end up disappointed with a tool that actually works exactly as designed. We'll get to it. If this is the kind of fix you're after, cheap, physics-based, no upsell, subscribe to the Independence Files. We cover one of these for a different part of the house, your RV, your boat, or your emergency setup every few days. Let's talk about what actually happens to a phone during an extended outage, because most emergency planning treats phone charging as an afterthought behind food and light. A modern smartphone battery typically holds enough charge for a day or two of moderate use under normal conditions, but during an emergency, usage patterns change completely. People check the news constantly, use flashlight apps for hours, and keep location services running to stay findable, all of which drains a battery far faster than an ordinary day. A phone that would normally last 2 days can be dead within 6 or 8 hours of heavy emergency use. A dead phone during an outage isn't just an inconvenience. It cuts off access to emergency alerts, weather updates, and the ability to reach anyone outside shouting distance. Portable power banks solve this under normal circumstances, but a power bank is itself just stored charge? Once it's empty, it's exactly as dead as the phone it was charging, and recharging it requires the same grid power that's already out. That's a bigger problem than it sounds like on paper, because most emergency response now assumes people have a working phone. Wireless emergency alerts, evacuation notices, and updates on when power or water will be restored are increasingly pushed exclusively through phones rather than radio or landline systems that used to serve the same purpose. A household with no way to recharge a single phone during a multi-day outage isn't just inconvenienced, it's effectively cut off from the primary channel authorities now use to communicate during exactly this kind of emergency. There's a timing problem baked into that, too. Most people only reach for a power bank once their phone is already low, which means the power bank itself needs to have been fully charged well before the outage started, and a power bank that's been sitting half-used in a drawer for months, forgotten between emergencies, often isn't. A stored battery only helps if someone remembered to keep it topped off in advance, which is a surprisingly common point of failure in otherwise well-stocked emergency kits. Here's what most people never consider until they're standing in a dark house with a dead phone. Your own body is a power source that never runs out of fuel as long as you're capable of turning a crank. It's a tiny, inefficient one compared to a wall outlet, but it's also one that doesn't depend on the grid, a battery that was charged in advance, or fuel that has to be purchased and stored ahead of time. So here's the bigger question worth sitting with. If human effort alone can keep one small device charged indefinitely, how much of emergency preparedness is actually about stockpiling stored energy in advance versus having a way to generate a small amount of new energy exactly when you need it, using nothing but the fact that you're a person capable of moving your arm? Think of it like the difference between a savings account and a part-time job. A power bank is a savings account, a fixed amount, set aside in advance, that eventually runs to zero no matter how carefully you spend it. A hand crank generator is closer to a part-time job, smaller and slower than a full-time paycheck, but it never runs out because it's tied to ongoing effort rather than a finite stored balance. Mechanically, a hand crank charger is a small direct current generator, sometimes called a dynamo, connected to a hand crank through a set of gears that multiply your hand's rotation speed into the much faster spin the generator's internal magnet and coil need to produce a usable electrical current. Turning the crank spins a magnet past a coil of wire, and that motion induces a small electrical current, the same basic principle used in every generator from a bicycle headlight dynamo to a hydroelectric dam, just scaled down to something a hand can drive. This isn't a novelty invented for emergency kits. Hand crank generators have been used in military field radios, trench telephones, and remote signaling equipment since at least the First World War, well before anyone was designing gear specifically for household blackouts. Soldiers with no access to batteries or fuel in the field needed a way to power communication equipment using nothing but manual effort, and the crank-driven dynamo solved that problem using the same electromagnetic principle still used today, just refined and miniaturized. Some of the clearest documentation of this comes from field radio manuals of the period, which specified exact crank speeds operators needed to maintain, usually a steady rotation counted in revolutions per minute to keep a signal strong enough to transmit reliably. That level of engineering precision, worked out for battlefield equipment with genuinely life-or-death stakes, is the same underlying discipline modern manufacturers apply when rating today's much smaller consumer devices. What's changed since those early field radios isn't the underlying physics, it's the efficiency of the components involved. Modern rare earth magnets and more efficient coil windings mean a small hand crank generator today produces meaningfully more usable current per crank rotation than the bulkier military equipment of a century ago, which is exactly why something that once required a large, heavy field unit now fits in the palm of a hand. Keep that crank-to-output relationship in mind. It's about to determine whether the number from the start of this video works in your favor or against it. Manufacturers of hand crank emergency chargers, companies building these specifically for emergency and outdoor use, publish output specifications in the same units used for any small generator, volts and milliamps produced at a given crank speed. That's a direct, testable engineering specification, not a marketing estimate, and it's exactly what lets someone calculate how much cranking time a given amount of phone charge actually requires, rather than guessing. Emergency preparedness communities, along with backpackers and off-grid travelers who have relied on these in the field rather than just kept one in a drawer, have documented consistent results, recovering meaningful phone charge, often somewhere in the range of 1 minute of talk time or standby per several minutes of steady cranking, using devices in this exact category. That's a second, independent confirmation sitting alongside the manufacturer specifications and the century of military precedent behind the same core mechanism. A number of those same reports come from multi-day backpacking trips rather than simulated tests, where cranking a charger was the only charging option available for days at a stretch, with no possibility of quietly switching to a wall outlet if the numbers did not work out. Those accounts tend to be unusually candid about both the real effort involved and the real, if modest, results, exactly the kind of honest, unglamorous data point that is more convincing than a polished product demonstration. 3 separate threads, each landing on the same underlying mechanism. A century of field-tested military hand crank generator design, current manufacturer output specifications that can be independently verified, and real-world reports from people who have actually used these devices under real conditions rather than just owning one. That's convergent evidence, not a single untested claim. It's worth being precise about what that evidence does not establish, though. Output varies meaningfully between specific models and even between individual users, since crank speed and consistency differ from person to person and device to device, and nobody has published a single, universal number that applies to every hand crank charger and every phone combination on the market. What does exist is a well-understood mechanical principle, verifiable manufacturer specifications for specific models, and consistently reported results that fall within the range that principle predicts. That's solid, reliable ground. It's just not a single guaranteed number, and it's worth setting expectations around a range rather than a promise. So if this mechanism is this well established, why isn't a hand crank charger sold as a household's primary emergency charging solution instead of a secondary novelty item tucked into survival kits? Here's the twist. It actually was the primary solution for decades in exactly the markets where it mattered most. It just wasn't sold to people planning for emergencies. It was sold to people who had no other option at all. Rural electrification programs in parts of the world without reliable grid access relied on hand crank and pedal-powered generators as genuinely primary equipment, not backup gear, for lighting and small communication devices well into the 20th century. The moment reliable grid power and cheap batteries arrived in a region, hand crank generators quietly disappeared from that market, not because the mechanism stopped working, but because a store shelf full of pre-charged batteries became more convenient than a device requiring ongoing effort. The instant convenient stored power became available and affordable. That's the real structural story. Hand crank charging isn't an overlooked or downplayed technology. It is a technology that solved a problem so completely in the markets that needed it most, that its own success made it look obsolete the moment an easier alternative showed up. It only reappears in emergency kits today because outages briefly recreate the exact condition, no reliable stored power available, that this technology was originally built to solve everywhere, all the time. There's a simpler reason underneath that history, too. A $9 hand crank charger, understood correctly and used properly, competes directly with much more expensive solar chargers and large power banks that carry far higher retail margins in markets where grid power is otherwise reliable. Nobody selling the pricier options benefits from explaining that a cheap, purely mechanical device can cover the same core need for keeping one phone minimally charged indefinitely. Product marketing also tends to favor devices that demonstrate well in a 30-second video ad. Plug it in, watch a percentage climb, done. A hand crank charger's honest demonstration involves several minutes of visible physical effort for a modest result, which simply doesn't compress into the same kind of satisfying before and after clip that sells a solar panel or a large battery pack. The device isn't less legitimate for being harder to market, it is just a worse fit for how most emergency products get sold today. As for what this actually involves, a basic hand crank generator unit with an integrated small output jack typically runs around $6, with a short USB charging cable to connect it to a phone, adding the remaining few dollars to reach the $9 total. The crank connects through an internal gear assembly to a small dynamo, and the dynamo's output feeds directly through the USB connection into the phone's charging port, exactly the same electrical pathway a wall charger would use, just with a hand-driven generator standing in for the wall outlet. The mechanism itself mirrors the same century-old field radio principle directly. Turning the crank at a decent pace spins the internal magnet past its coil fast enough to induce a usable current, which flows straight into the phone through the same charging circuitry the phone already uses for any other charger. Slowing down or turning unevenly produces noticeably less current, which is exactly why some people report weaker results than others using the identical device. The difference usually comes down to how evenly they are actually cranking, not a flaw in the hardware itself. Some units include a small internal capacitor or tiny buffer battery between the dynamo and the USB output, smoothing out the naturally uneven current produced by hand cranking into something steadier before it ever reaches the phone. That small addition does not change the underlying physics. It just protects the phone's charging circuitry from an inconsistent power supply, the same way a surge protector smooths out irregular household current without generating any power of its own. Now, back to the number I mentioned at the start, the one that separates a realistic expectation from a disappointing one. Most compact hand crank chargers in this price range produce roughly 1 minute of phone talk time or standby charge for every 3 to 5 minutes of steady cranking, though this varies by specific model and by phone. That means recovering even 30 minutes of usable phone time could require a genuinely tiring stretch of 90 minutes to 2.5 hours of continuous cranking, a real, sustained physical effort, not a quick 30-second fix. That number is exactly why this device makes sense as a last resort backup for keeping a phone alive for essential calls and alerts, rather than as a way to keep a phone running normally through a multi-day outage. Understanding that distinction before relying on one is what separates a useful tool from a frustrating disappointment. There are other real limits worth being upfront about here too. Modern smartphones with large batteries are far less efficient to charge this way than older, simpler phones with small batteries were, and a device built for an older generation of phones may charge a modern smartphone more slowly than its specifications suggest, simply because today's phone batteries hold dramatically more capacity than the devices these chargers were originally designed around. Physical fatigue is a real constraint too, not just an inconvenience. Cranking steadily for the better part of an hour is genuinely tiring, and output tends to drop as crank speed slows with fatigue, which means the realistic use case here is short, targeted charging sessions aimed at essential communication, not an attempt to fully charge a dead phone in one sitting. Build quality varies significantly across cheap hand crank chargers on the market, and the internal gearing in low-quality units can wear out or strip under repeated heavy use, a detail worth checking in reviews before buying, since a broken crank mechanism defeats the entire purpose of a device meant to work when nothing else does. Temperature and hand condition affect performance too, in ways that rarely get mentioned. Cold hands and cold gearing both make steady, sustained cranking noticeably harder to maintain, which is worth knowing if this is being kept as a winter emergency backup rather than a fair weather one. The same device that performs well in a warm living room test may feel considerably harder to use reliably during an actual winter outage. This isn't a substitute for a proper power bank or a larger battery setup, and it's not being presented as one. It solves exactly one specific problem: a way to generate a small amount of emergency phone charge with nothing but manual effort when every other option has already run out. Nothing more and nothing less than that. Which loops back to where this started. The same hand-crank dynamo principle that charges a phone works identically in hand-crank emergency radios and hand-crank flashlights, just routed to a different output. It's the same mechanical to electrical conversion, only the device receiving that current changes. A hand-crank radio, for comparison, needs far less power than a phone to run. Enough to hear an emergency broadcast draws only a small fraction of what even a brief phone charge requires, which is why a radio built around the same dynamo mechanism can often run for extended periods on a fraction of the cranking effort a meaningful phone charge demands. The device changes. The underlying arithmetic of turning manual effort into stored electrical energy stays exactly the same. Every outage eventually narrows down to the same question. Once every stored source of power in the house has run dry, is there still a way to generate something new using nothing but the effort you're personally able to put in? If you've used one of these yourself, or you're wondering how much cranking your specific phone would actually need, drop it in the comments below. I read all of them, and I'll do my best to help you work out the math.